All right, good day and welcome back to Everything Mathematics. This week we're going to focus on simultaneous equation. And today we're going to specifically look at how to solve a simultaneous equation when the coefficients are the same. And just to clarify a few terms just before we get started, the coefficient of an equation is simply whatever number is standing of whatever unknown value. So generally, for example, if we have x plus y is equal to, let's say, 3, the coefficient of x will be whatever number is represented just before the x. In this case, because there's no number, then it's understood that there is a 1. So the coefficient here of x would be 1, and likewise the coefficient of y would be the number 1. That's just to get that off the way. It's also wise to know, and I'll just mention it, whenever we're dealing with simultaneous equations, as far as I know, there are 3 different ways to solve them. One of them, which I would have done at least 2 weeks ago, which is using matrices. The other way is using, of course, a graph, which is called the graphical method. And when it comes to 2 by 2, the other way in which you could solve it is that of using substitution and elimination. Of course, there are other ways, so I shouldn't say just 3, because of course you could use things like row echelon and all these things, but I don't know, you use that for more higher level matrices. When I say higher levels, bigger matrices, 3 by 3, 4 by 4, you would really want to use such a strategy with a 2 by 2, which will be what we'll be focusing on today to solve matrices. So let's talk about what we are expected to do. So generally, when we have, and of course, I'm taking it for granted that we all have a basic understanding of a linear equation. You could simply think of a linear equation as an equation that when drawn, it will give you a straight line. Good. So generally, if we recall from geometry, y is equal to mx plus c, where y, of course, it's your y, now your y-intercept, your y point, x is your x point, m is your gradient, and c is your y-intercept. So when we have a linear equation, it simply means that we will have 2 linear equations which we're trying to solve at the same time, thus simultaneous. Simultaneous simply means, in this case, that we're trying to find the value of 2 unknowns, but at the same time. And in the way in which we'll do it is simply elimination and substitution. We'll eliminate one to get a value, and when we get that one value, we find the other value. So let's just start with an example. And with the example, of course, I'll explain my way as I go. So supposing we have the equation x plus 3y is equal to 13, and then we have x plus 2y is equal to 9. Generally, sometimes we just label the equation, so we might consider this one to be equation 1, and then we consider this one to be equation 2. That's not a must, but it's something that people do. Right. So the essence of simultaneous equation solving or solution is this. We have to pick a value, or we have to pick an unknown, whether x or whether y. Whichever one we choose, there is one condition that has to exist. The coefficient must be the same. And today, as I said, the coefficients that we'll be solving, they will be the same. If they're not the same, you can make them the same, but we're going to address those types tomorrow, God's will. So in this case, we want to get rid of the x. Why? Because it have the same coefficient. In other words, we could say that there is a 1 in front of this x, and there is also a 1 in front of this x. So they're the same. Good. Once we establish that, the other thing is to decide whether we add or subtract equation 1 from equation 2. And whether you add or subtract, the aim is to ensure that one of the terms in which you're eliminating are eliminated. For example, think of it this way. It's like if I have 8 and I have 8 here, and I want to get 0 as an answer. If this is the case, which is the best sign that I should put inside here? Will it be a minus sign or will it be an addition sign? So this is the whole game here, really. We have to choose whether we're adding or subtracting in order to end up with 0. And by 0, in this case, it means we are eliminating one of the unknown terms. So in this case here, we will subtract. Why? Because this x is positive and this x is positive. So if we take away this x from this x here, we will end up with 0, which is what we want. But we don't just subtract the x's, we then subtract every corresponding term to each other. So the y term will be subtracted from the y corresponding, and the constant value 13 here will be deducted from the constant value 9. So when I do that, I have now 3y minus 2y, that will just leave me with y. And that will be equal to 13 minus 9, which will give me 4. Oh, this one worked out quite straightforward. So then we have y is equal to 4. And now that we know that y is equal to 4, the next thing we do now is substitute. So we substitute the value of y into either equation 1 or equation 2. So we choose which equation we want to substitute it into. We could choose this one if we want, or we could choose this one if we want, whichever one fancies you best. I will choose equation 2 here. So in other words, I am subbing, so sub y equal to 4 into, just making my little statement, into equation 2. And when I do that, initially, let me just go back so we can see equation 2. Equation 2 was x plus 2y is equal to 9. That's my equation 2 there. But now I know that y is 4. So that will be x plus 2. And instead of y inside there, now I will put 4, right? And that will be equal to 9. And once I solve that, I will get the value for x. So that will give me now x plus 8 is equal to 9. And as a result now, x will be equal to 9 minus 8. Subject of the formula, we just bring over the 8 and we subtract it. So x will be equal to 1. So all we're saying here now, so our final solution is simply telling us that y is equal to 4 and x is equal to 1. Easy does it. So this will be our final answer for this pair of simultaneous equation. Where's the simultaneous equation? Yes, right up here. Oh, this thing is giving me trouble today. Good. So this pair of simultaneous equation will give us a solution of y is equal to 4 and y is equal to 1. The other thing we need to understand, should I explain this? Yes, I will. The other thing you need to understand, and I guess this is just to help us in case we want to solve it as a graph. What these two values is telling us here, y is equal to 4 and x is equal to 1, it simply tells us that if we go to draw, so imagine we have our Cartesian plane here, and this is our y-axis, and of course this is our x-axis. If we go to draw these two equations, so we draw one like this and we draw one like this, that simply tells us that at this point here, y will be equal to 4, the y-axis will be equal to 4 at this point, and on the x-axis will be equal to 1. I should have drawn this closer to here because 1 will be definitely somewhere here. But again, just imagine we have a wider scale. Right, so yes, on the y-axis and on the x-axis, these two lines will actually be intersecting. And right there and then, basically, I just taught you how to solve a simultaneous equation graphically. We just have to draw the two lines, and wherever they meet, that will be the answer to the simultaneous equation. It's as simple as that. Good. Let's do another example. So let's do another example. So here we have x minus 2y is equal to 2. And then we have x plus 2y is equal to negative 2. And again, let's call this one equation 1. Let's call this one equation 2. And here notice that both the x's have the same coefficient and the y's have the same coefficient. So in this one, it's pretty open. We could choose whether to eliminate the x or the y. It's totally up to us. Just now there we did x. So let's do y now because the condition is already met. There is a 2 in front of the y, there is a 2 in front of the y on both equations. So how do I eliminate minus 2 from positive 2? Simple, by adding. Good. So in essence, again, remember, it's like we have minus 2. What sign do we put here? To positive 2 to end up with 0. And the sign that we put here will be a positive because minus 2 plus 2 will give us 0. But of course, we're not just adding those two, we're adding everything else. So x plus x, that will be 2x. Minus 2y plus 2y, that would give us 0. And on the other side, 2 plus negative y, that will give us, sorry, 2 plus negative 2, that's the same scenario we just experienced there, that will give us 0. So in essence, now we're saying that 2x is equal to 0. As a result, x will be equal to 0. And in case we wondering how we got x to be equal to 0, remember, if we have 2x, we'll do this one in a different color. So if we have 2x equal to 0, and we want to make it a substitute formula, we divide by 2, we divide by 2. These 2 cancels these 2, so that leaves x equal to 0, because 0 divided by 2 is 0. So that's how we end up with 0 there. And now that we know what is x, we simply substitute it into either equation. We could choose equation 1 or we could choose equation 2. Just know that I choose equation 2, so let me just choose equation 1 this time. So again, sub x equal to 0 into, and in this case, let's use equation 1. Remember, it doesn't matter which equation you choose, it should both give you the same answer. Should both give you the same answer. Although I'm saying here now, you wouldn't quite get the same, but I have to have with that. Right, so when x is equal to 0, and if I use equation 1 is x minus 2y. So I have x minus 2y is equal to 2, I think. Let me go back to check. Yes, equal to 2. So that's what I have there. X minus 2y is equal to 2. And remember, I know that x is 0. X is 0. So instead of writing x, again, I just put 0 and I continue. Minus 2y is equal to 2. And again, here we just divide by 2y. This is the same as really saying 2y is equal to 2. And if we divide both sides by negative 2, we will end up with y is equal to negative 1. And as I was saying, it doesn't matter which equation you choose, you should end up with the same thing. Maybe I could just do it on the side here just to prove it. Some people think that based on which equation you choose, it makes a difference. No. Look at this one here. If x is equal to 0, again, you would have been dividing 2y. So this 2 would have been divided by this negative 2. And you would still end up with negative 1. Right? So I'll just show you that just for you to see. Just a quick crash course. And yes, this brings us to the end. So x, when x is equal to 0, guess what? Y is equal to negative 1. And if you draw that, you will see that on a graph. So in other words, this y here is also the y-intercept. In a way, you could say that, because x is at 0. So if you go to draw this, for example, if you go to draw this, again, we have x here and we have y here. So when x is equal to 0, 0 for x will be here, y will be negative 1. So that means that those lines will be intersecting at this point. 0 for x, 0, that's the origin, and minus 1. So that will be the intersecting point here. So that's why I said the y, in this case, also end up being the y-intercept. So the value for y is also the y-intercept. Good. Let's do one more question, and that should bring us to the end of today's video. So I'll give you a chance to work it out, or of course, this is where you could pause it and give it a shot first before I step in. So 3x plus y is equal to 11, and then we have x plus y is equal to 3. This is equation 1, and this is equation 2. Good. And here, again, we're looking to see which coefficient is the same, which is the focus of our video today, solving simultaneous equation when the coefficients are already the same. Tomorrow, as I said, we're going to focus when the coefficients are not the same. So here we could see that y, there is a 1 in front of the y, and there is a 1 in front of this y here. So we could go about by simplifying the y, eliminating the y. And since they're both positive, to end up with 0, we subtract. So, and again, remember, we're not just subtracting the y's, we're subtracting every corresponding term with itself. So 3x minus x, that would give us 2x. Y minus y, that would give us 0. And 11 minus 3, that would give us 8, I think. Yes, 8 is correct. So here we have 2x is equal to 8. And if I divide here by 2, I do the same on the other side. That would leave me with x equal to 4. Rules of equation, whatever I do on one side, you do on the other side to ensure that you sustain balance. And then we choose one of the equations. I will choose the second equation because it's a lot easier. So I'm subbing. I'm going to sub x is equal to 4 into equation what? Equation 2. Equation 2 was the easier one. Equation 2, we just had x, well, for me, although it don't matter which one you choose, as I said, it should give you the same thing. X plus y is equal to 3. And we know that x is 4. So instead of x, I am writing in 4. So I said 4, and then I continue. 4 plus y is equal to 3. Because remember, x is 4. We just found x to be 4. So we want to know what is y when x is 4. And when we transpose the 4, we will end up with y is equal to 3. And the 4, when it's sent on the other side, will be minus 4. Hope we could see that. And at the ending of the day, y will be equal to -1. That's our answer. So when x is equal to 4, y is equal to -1. Pretty much. That's it. So this will bring us to the end of today's video. I trust that this was clear enough for you. But of course, if it's not clear, feel free to leave a comment, leave a question in the comment section below. And until the next time, see you again. You take care.